Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. The details are set for the next TWiML online meetup. Mark your calendars. The September meetup will be held on Tuesday the 12th from 3 to 4 p.m. Pacific Time. The discussion will be led by Nikola Kucherova, who will be presenting Learning Long-Term Dependencies with Gradient Descent is Difficult by Yoshua Bengio and Company. This is one of the classic papers on recurrent neural networks, so you won't want to miss it. For additional details or to join the meetup, head over to twimlai.com/meetup. If you missed the first meetup, the recording is available on that page as well. My guest this week is Jennifer Prendki. That name might sound familiar as she was one of the great speakers from my Future of Data Summit back in May. At the time, Jennifer was a senior data science manager and principal data scientist at Walmart Labs, but she's since moved on to become head of data science at Atlassian. Back at the summit, Jennifer gave an awesome talk on what she calls Data Mixology, the slides for which can be found on the show notes page at twimlai.com/talk/46. Our conversation this time begins with a recap of that talk, after which we shift our focus to some of the practices she helped develop and implement at Walmart around the measurement and management of machine learning models in production, and more generally, building agile processes and teams for machine learning. Before we jump in, I want to give a big thank you to our friends at Cloudera for sponsoring this show. You probably think of Cloudera primarily as the Hadoop company, and you're not wrong for that. But did you know they also offer software for data science and deep learning? Yep, they do. The idea is pretty simple. If you work for a large enterprise, you probably already have Hadoop in place, and your Hadoop cluster is filled with lots of data that you want to use in building your models. But you still need to easily access that data, process it using the latest open source tools, and harness bursts of compute power to train your models. This is where Cloudera's Data Science Workbench comes in. With the Data Science Workbench, Cloudera can help you get up and running with deep learning without massive new investments by implementing an on-demand, self-service deep learning platform on existing CDH clusters. From a tech perspective, Data Science Workbench is pretty neat. It uses Kubernetes to transparently schedule workloads across the cluster, supporting R, Python, and Scala, and deep learning frameworks like TensorFlow, Keras, Caffe, and Theano. And, as of last month's 1.1 release, GPUs on the Hadoop cluster are fully supported. The folks at Cloudera are so confident that you're going to like what you see that for a limited time, they're offering a drone to qualified participants who register for a demo of the Data Science Workbench. For your demo and drone, visit twimlai.com/Cloudera. And now, on to the show. All right, everyone, I am on the line with Jennifer Prendki. Jennifer is a senior data science manager at Walmart Labs, specializing in machine learning, and I am super excited to have her on the line with me. Jennifer, welcome to the show.
Hi, Sam. Nice to be here.
Yeah, nice to have you here, and it is so nice to speak with you again. Folks recognize Jennifer's name. It's because Jennifer was one of the speakers at the Future of Data Summit, and she so graciously offered to spend some time with us to talk a little bit about what she's doing at Walmart Labs. Before we jump into that, Jennifer, why don't we have you spend a little bit of time talking about your background and how you ended up working in machine learning at Walmart?
Sure. So actually, when I tell people what my background is, they're a little bit surprised because I'm actually a particle physicist originally. And so the reason why it's not as crazy as you might think at first is that I was doing the type of particle physics where you have lots of data to treat. And so I was actually working with huge amounts of data even before the word data science became as trendy as it is today. So, I mean, the reason why I eventually switched to pure data science and specifically retail data science is that I was looking for, like lots of data, interesting data to work with. And so it actually turns out that retail has lots of very interesting challenges for someone passionate with data to work with. So here I am, right?
Fantastic. Fantastic. Can you tell us a little bit about the talk that you gave at the summit? What were your goals for that presentation?
Yeah, so my topic for the summit was something I call data mixology, right? I mean, so my goal was to try to, sensitize people to the fact that the real challenge with big data today is not necessarily velocity or volume as people think. It's really about variety, right? Because when you start plugging in several data sources, sometimes you have to rethink your model entirely, and you have to deal with all challenges related to data silos and understanding the quality of the data coming from different sources. And so yeah, I mean, I really thought that this was a topic that was not necessarily covered enough in the different conferences that I had been around recently. So I thought it was an interesting topic to cover.
It was definitely an interesting topic, and it was clear as you were delivering it that it came from your experience. How did these issues of silos manifest themselves in your world?
No, I mean, so the way it come around on my experience is that I recently started a new team where essentially the goal is to try to use both stores data from Walmart and online data from Walmart and bring them together. And
Okay.
so in the Walmart world, truth is, I mean, the Walmart e-commerce business and the Walmart stores business are essentially separated. It's not the same people. And even the data lives in separate places. It's not necessarily trivial for an e-commerce data scientist at Walmart to access the store sales data, for example. And so as we were trying to bring these two worlds together, I actually came to discover firsthand all the different challenges you have from bringing different data sources together, even when it comes from the same company. So this is exactly how I came, to come to speak about this topic.
And a lot of companies are pursuing ideas like data lakes or, that idea by various different names. Is that something that you guys ended up doing, or did you take a different approach to integrating all this data?
No, we're absolutely taking that direction, right? I mean, but as you can imagine, right? I mean, the challenge for Walmart is really that you have a Walmart e-commerce, which is a tech company that is more recent and really like a typical Silicon Valley company. And on the other hand, this huge Walmart company, legacy company that has lots of data. They actually been gathering data for a long time now. I think they were one of the first companies actually realized that data was so important. And so you really have to deal with different types of systems altogether. We're not necessarily using the same technology. So we're definitely after the creation of a data lake where all data scientists across the company would be able to come and look at the same data, but it's a long road, right? I think every company that is trying to tackle this challenge knows that it is a long road and it requires a lot of different skill set and lots of different people and expertise to actually achieve the goal.
It's funny. I think the way that some of the vendors in the space talk about it is that you just set up a Hadoop cluster and run some ETL jobs and you'll have a data lake. What are some of the challenges that you ran into and what makes the road long?
No, I'll give you a specific example. So one of the very interesting data sets that everybody across the company wants to work with is the online engagement data, right? I mean, essentially, which items does the customer actually click on and what do they eventually buy, right? And so this is a data set that, for example, stores doesn't have access to because they don't have engagement. They just have the final purchases. So they don't have any way to measure properly the interest of a customer as long as they don't purchase something. And so people keep actually getting this data from us and they actually get a data dump, right? And they don't necessarily create exhaustive signal pipelines to get this real time. And so there are lots of different versions of this data that live across the company.
Oh, wow.
And so whenever we, Walmart e-commerce, make a change to this data, it's not easy to communicate these changes to other teams. And so one of the challenges is you don't necessarily know anymore which is the original source of truth. And
Right.
so in that specific case, it might be easier because you know who the owner is, but in some other cases, we don't necessarily even know where the data is coming from. And so everybody's interested in the same data, but this data exists in multiple versions. And it's actually very hard to come up with like a procedure to actually figure out which one is the best one and which one is the accurate source of truth.
Mm-hmm. That actually gives us a really interesting segue to one of the main topics that I wanted to dig in with you here on the podcast. And that is one of the interesting aspects of your role is leading a team that's focused on measuring and auditing for the various machine learning models at Walmart. And you mentioned, the source of truth and data provenance is kind of one, small aspect of that. Can you tell us a little bit about your role and some of the type of work that you're focused on in that role?
Right, definitely. So I'm actually part of a group called the Search Algorithms team. So we're essentially the group of data scientists and machine learning experts that take care of all machine learning algorithms that you would see at work on the Walmart.com page, right? So that includes learning to rank algorithms and involves everything related to the understanding of the customer. So we actually split down the responsibilities on my team into 3 different portions. So there is something called the perceive team, which is essentially in charge of trying to understand what the customer wants, right? So query understanding, it involves a lot of natural language processing algorithms, auto-completion algorithms, spell checking algorithms would be their responsibilities.
Okay.
Then there is the guide team. So the guide team is about learning to rank and showing the right items once you think you understand what the customer is looking for. And then we have this measure team, which is my team that essentially takes care of helping the others understand their weaknesses, suggest new data sets that they can use, suggest best practices, make sure that these other algorithms are retrained properly at the proper frequency, catch problems early on. So we're essentially creating models to take care of other models, right? So we create specific measurement scoring systems that range from data quality to, like customer satisfaction. And so we're trying to bring essentially we're the team that gets a real profound understanding of the other algorithms in order to help the others understand what they need to do to make it even better.
And are you primarily focused on helping the search teams, or do you also work with teams outside of search that are doing data science and machine learning?
So that's an interesting question, because my original mission was definitely to help the search team. But it turns out that we are the only measure team within the company. And so once people started understanding what we're doing, we actually get lots of requests from other teams to actually help them as well, right? Search is obviously an area where you have lots of different teams that are involved with us, right? So we're really focusing on search, but you can imagine that the team in charge of the inventory and the catalog is also teams that we're very closely working with. So it's pretty natural that we also bring measurements for them. And so another area where we're also partnering with other teams is that we actually created an entire process called machine learning lifecycle management, which is essentially a checklist of things that we believe all machine learning models people who work on machine learning models should do before pushing something to production. And so it actually turns out that we have a pretty efficient system now. So, we're essentially requiring data scientists to provide, a very clear view of what the accuracy is, but also what the performance of their algorithm is in terms of the amount of CPU that their model consume when they're retraining and so forth and so on. And so we are not trying to expand this process to the entire e-commerce section of Walmart. And actually turns out that lots of people are interested by that, because the challenge in data science is oftentimes in a company like ours, you have machine learning engineers who are really engineering people who don't necessarily understand the limitations of data science, properly speaking, right? So they are not necessarily trained to think in terms of evaluating the accuracy and making the proper checks before sending something to production. They are the type of people who are really looking forward to see their model in action, and they don't necessarily take the time to evaluate the statistical performance of the models. And so creating this, this process is really making sure that everybody's on the same page and that things are running properly in production.
It's interesting. It makes me think of a few years ago when the software development community went through this process of like industrializing the delivery of software, and that resulted in ideas like lean and agile methodologies and DevOps and things like that. And it sounds like you guys are kind of on the, the cutting edge of an industrialization wave of machine learning, not to be confused at all with the industrial AI line of inquiry that we've talked about here on the podcast recently. But I love this idea of a machine learning lifecycle model. What can you tell us about that model and the various steps and stages and requirements that you've put in place for the teams there?
Right. No, I mean, you're definitely right about that being like a new wave of Agile, right? I mean, Agile for data science or machine learning. This is exactly what we're after. Mm-hmm. So, I mean, as we were putting the first steps together, I actually came to realize that it is really a cultural problem, right? I mean, because if you want to reach the stage where things are done properly, you're really about trying to fix tech debt. But people usually think of tech debt as code debt, right? I mean, I think this is the way that people came to know code debt. And the truth is, tech debt is much more than this, right? I mean, there are actually more pieces to tech debt than just code debt. There is definitely data debt related to the quality of your data, but also the data sets that you may not be using, but your competitors are using, right? I mean, so if you're actually in a situation where, for example, we know, that Amazon is using a specific data set that we have, but we are not using currently, we are in a data debt situation, right? Then there is the notion of system debt. So the case where you're using legacy systems and you're not improving and getting to use the latest versions of a specific software or the newest cutting edge software that is in trend in the industry. And then you have machine learning debt. So machine learning debt is really when you're using a machine learning model not to the best of its ability, right? I mean, so for example, if you don't understand at which frequency you should be retraining a model, you don't monitor the inputs and outputs, it's definitely also a situation that you have to take care of. So, I mean, the steps that, when somebody asks me what should I do to actually get started with, automation and try to basically audit my models, what should I do? So my answer to that is it's not necessarily something that's very complicated. It's really about a process and also creating a culture in your company where everybody understands that making things right is important. And so it really depends on the kind of model you're dealing with. But usually one thing I suggest everybody should do is make sure that you document everything that you're doing, right? I mean, so it may sound like a cheesy answer, but it's definitely super important. We actually turned out that most of the times when we didn't have a model performing well enough, it wasn't necessarily because of the model itself. It was because we didn't have a clear understanding of what the model was doing, right? I mean, so we were not able to reproduce the same model. There was a lack of transparency. And so, for example, you would have a new engineer coming over and trying to take over the project, and they wouldn't even know how the model was built. Mm-hmm. So the other thing is it's extremely important that you have a clear understanding of what your failures and weaknesses were, so that, I mean, people tend to forget that in the concept of machine learning lifecycle management, there is the word cycle, right? I mean, so there is an opportunity for everybody to learn about their weaknesses in order to make sure that the next iteration of your model is better.
Right.
And, so definitely think about the culture that you have to bring in your company and make sure that you're keeping track of everything you're doing, that it is very clear the data you're using. It is very clear that you understand the quality of your data and you understand your challenges.
On the various teams there, can you tell me a little bit about the relationship between data scientists and people with a statistical orientation and developers and engineers?
Yeah, I can absolutely tell you about that. So actually my team has statistical analysts, data scientists, and machine learning engineers. And so people sometimes struggle to understand what the difference is. So really in our view, statistical analysts are people who know how to play with the data really, really well. Mm-hmm. So they essentially can get you, a very clear understanding of whether your data has sufficient entropy and sufficient variance for you to build a model, and then can give you answers very quickly to get started. The data scientist is actually the person that would, I would say, like prototype a model, right? I mean, so once you have an understanding that your data is good enough for you to solve a specific problem, the data scientist will come up with the solution and essentially try to assess which is the best type of machine learning model for you to solve that problem. Mm-hmm. So we don't necessarily expect like the statistical analyst to be someone who's an expert in machine learning. I mean, of course, they have some understanding, but they are not the persons that be in charge of creating a model. And then the machine learning engineer is someone that knows how to optimize this machine learning model and make it work at scale.
Okay.
So they're really like focusing on making everything efficient and I mean, they really have the ability to push that to production. So having all this skill set together in one team has been really helpful for us because it really helps us move things to production really quickly.
One of the things I've seen in the past with organizations that have a model similar to yours, although I think less sophisticated in the way you are managing it in the machine learning lifecycle processes that you've introduced, is a little bit of friction in kind of the interface between the data scientists and the machine learning engineers, where you would have a data scientist, create a model, kind of code it up, using, maybe even a set of tools that are not the set of tools that the ML engineers are working with, kind of throw it over the wall, and then have this machine learning engineer who, is maybe less sophisticated in understanding the model, try to implement it often in, going from, Python, for example, to Java or something like that. And that both resulting in, creating an opportunity for the introduction of errors as well as slowing cycle time and iteration time just because of the back and forth over this barrier. How have you guys seen that at all? And how have you addressed it?
So I definitely see how that problem can arise, right? I mean, so I think like at the very beginning when this team was still very nascent, I mean, we definitely had that problem. The way we kind of solved it is that there is actually a very decent overlap between the data scientist and the machine learning engineer. And so usually the data scientist would actually code something which is pretty close to what would end up being in production, except that it is not necessarily functioning at scale, right? I mean, so usually they use the same language. So
okay.
that's for sure. The other thing is we make sure that I have my machine learning engineers and my data scientists work in pairs.
Okay.
So the machine learning engineer is actually involved in the early stages as well, but he's not the tech lead for that portion, right? I mean, so he actually gets to be involved and immerse with the model like very early on, which gives him some more sophisticated understanding of the model that makes it easier for him or her to actually push it to production later. So we don't really have like this transition phase. It's really like the entire pair is working throughout the process. Except that the first phase is the phase where the data scientist is in charge, and the last phase is the phase where the machine learning person is in charge.
Okay. That's another really adaptation of the Agile idea, or at least the pair programming notion of Agile to
absolutely
this machine learning lifecycle. Interesting. So you develop these models, you get them in production, and then you are tasked with tracking and measuring and auditing their performance, not just when you're putting them into production, but over time. Tell us a little bit about that cycle.
Yeah, sure. So, I mean, the interesting thing was, like at first when we came up with this new model of having like an external team kind of measuring things was pretty interesting, right? Because our other teams up to that point in time, they were actually used to essentially come up with a success metric that they would use to actually essentially build their model. And they would actually use the same success metric for measuring and auditing this model themselves, right? And so the value proposition was that you're kind of in a situation where you have a conflict of interest, right? Not only that, and even if you want to be like really truthful, I mean, if the same person is actually coming up with measurements and actually assessing their own models, they don't necessarily see things in a different light, right? I mean, so the value proposition here is that you have a different person that doesn't know or knows very little about the model auditing things and actually come up with their own definition of what success means for that model, right?
Mm-hmm.
So we had a little bit of tension at the beginning, as you can imagine, right? Because it's almost like as you use the word auditing, right? I mean, that's definitely what we do, right? I mean, so you're in a situation where everybody's wondering, like, well, what is the status of my model? Are these guys are going to find anything wrong with my model? So it took some time for us to actually like make it very clear that we are not here to actually judge your work. We're actually here to help you improve it, right? I mean,
Right,
so
right.
that was, but I mean, I think everybody's very comfortable right now that we're actually in charge of, like making sure of the quality of the model. So we have a very good dynamic with the other teams right now.
When it comes to measuring the performance of the models that you guys are using, are you focusing on business metrics or technical model performance metrics or a combination of both?
It's definitely a combination of both. I mean, so the reason why we believe that there should be an entire team focused on this is, as you can imagine, there is not one single metric per model, right?
Sure.
So we actually have like some models actually use like several metrics or several tens of metrics to actually make sure that we have a comprehensive view of how the model is performing. And so it ranges from, how accurate is the model to how efficient is the model in terms of, is it using too much CPU, as I mentioned earlier? And is it impacting the customer in a proper way, right? So our belief is that you should have a specific metric for every single model separately. So in retail, it is pretty traditional to use typically like the number of add to carts or the number of clicks or even the revenue as a measurement of success when you,
right.
For example, run A/B tests.
Right.
So our belief is that because you have these two steps, right? Understanding the customer through perceive and guiding the customer through guide, we believe that you should have metrics specific to each one of these portions specifically, because otherwise you're looking at all models in terms of add to carts. It doesn't really make sense, right? Because the perception phase is really about understanding the customer, not necessarily. So for example, if I have a drop in add to carts, it is possible that my new perceive algorithm is really working well, but because there is a bottleneck with the guide phase, I won't see that this model is performing well, right? I mean, so really making sure that you have very narrow and very specific metrics, even if it means having many of them, is definitely working very well for us.
I guess I have mixed feelings about that hearing it. I wonder about local minima, local maxima, or I guess probably a better way to put it is unit tests versus integration tests or system tests. Like, what if you're creating, you have a measure that the perceived team is able to maximize, but it doesn't maximize the overall, metric of something like revenue or an add to cart. How do you manage that?
That's a very good question. Actually, we see that problem very often. So basically, like you would have a new perceive algorithm that performs really well, but you actually see that it actually causes the guide performance to drop, right? I mean, so you definitely have this kind of cannibalization problems. Let me give you an example, right? I mean, so we actually figured at some point that when you're actually improving the accuracy or the efficiency of your auto-completion algorithms, it essentially drops the performance of the spell check algorithm. Why? Because if people can use the auto-completion algorithm, they are not going to finish entering the queries by end, which means that the spell checking algorithm is not called that often, right? I mean, it's pretty logical if you think about it. So I mean, this is exactly the kind of thing you want to observe, because in that specific scenario, that essentially allows us to say, you know what, it's worth investing more time making a perfect auto-completion algorithm rather than making a perfect spell check algorithm. And so you actually use these inefficiencies to determine which algorithm you should focus on.
Interesting. So a related question that I've had for folks in the retail space is around short-sighted versus long-sighted models. And this, an example here might be, as we talked about, it's pretty common to optimize your models around add to carts or even, short-term, even immediate revenue creation or even something like profitability to be kind of at one level higher in business impact. But I wonder if when you're doing that, if it's possible that you are sub-optimizing the broader metric like customer lifetime value or something along those lines. Is that something that you think about there at all?
No, we definitely have that as a metric. So you suggested like a customer lifetime value. This is one of the metrics you would monitor against the entire process, which is why I say that you need to have several metrics for every model, right? I mean, so we make sure that we keep track of all different aspects and dimensions of the problem. But as in always in business, at the end of the day, you have to follow a business decision as well, right? I mean, so if the goal of the company is to increase revenue drastically over the next quarter, I mean, you at the end of the day, you align your decision based on this as well, right? I mean, at the end of the day, the final choice of which algorithm you should improve comes down to a business decisions. Our goal is really to make sure that they have all information in hand and handy to actually make a decision based on that, right? I mean, so whatever they decide to do, we make sure that they are aware that if they choose to do a specific or take a specific decision, it may impact customer lifetime value or these kind of things.
Are there other instances where you're working to balance short-term versus long-term optimization targets?
Well, I mean, obviously as far as I've seen things at Walmart so far is really like this kind of optimization would come down to a business decision, right? I mean, so I don't think we've already reached a level where we can forecast or predict the future well enough to actually get to this to like a comprehensive knowledge that brings everybody on the same page for sure.
Right. Are you in the process of auditing these various teams? Do you have a list, either formal or in your head of, these are the top N things that people tend to do wrong? Or put another way, what's your advice for folks that, want to learn from, what you've learned from your teams on, how they should approach modeling?
Right, definitely. So I would see three things that I believe are good takeaways for everybody who's trying to tackle this problem. So the first one is definitely what I was saying before, making sure you document everything, especially in large organizations where the turnover of your employees is really high, right? I mean, you want to make sure that if something went wrong with a past model, at least you know what went wrong and you have the ability of fixing this in the next iteration. And so make sure that anyone can actually grab that model and reproduce the same results. That's one thing. The other thing is I actually noticed that many times when our models are unsuccessful, it is essentially not due to a performance issue from the model side. It's actually a problem with the inputs. So a failure in one of the systems, or like typically in retail, something you could see happening is a seasonality pattern, right? I mean, so basically your model was meant to function well for, your inputs to be in a specific range. And you have to make sure that it is still the same range, right? I mean, so actually monitoring the inputs and the outputs goes a very long way. It doesn't necessarily mean that you have to monitor things very closely, but you essentially get a sense that the average number of add to carts you see on a specific day is still pretty close to what you would expect them and what it was when you actually trained your model.
Right.
The last thing is, I would say that one issue I've seen as well is not necessarily an issue, but data scientists tend to, I would say not necessarily overfit in the way you would think about it, but use too much data for the models. So something that we're actually requiring from all our data scientists now is that when they suggest a specific amount of data to retrain the models, we actually ask them to train the exact same model with a lesser amount of data. And they actually do that for several data points. And we actually build this curve of, essentially a CPU consumption versus accuracy of the model. And actually turned out that in our case, many people were using, I would say 4 times too much data compared to what was actually needed. So essentially that means that you're using 4 times too much CPU, right? I mean, it's taking you 4 times longer to train these models. So essentially, of course, it's better to use more data, but if you're going to increase your accuracy by just 1% by throwing 4 times as much data, it doesn't really make sense, right? I mean, so I think that data scientists are not trained to think in terms of money optimization, right? I mean, so this is something that we've made sure now that everybody is like actually aware of, like conscious of the amount of CPU they're using when they're training their models.
And have you developed a set of rules of thumb? Is there a way to generalize that, or is the right way for them to, do they always need to run the models with 4 different data points and understand where the kind of that utility curve and pick the right point on it?
This is the way we're functioning right now, right? I mean, so I mean, of course, for the future, I have some hope of coming up with it's a very iterative process, right? I mean, so the way we've been thinking about it is that, as we ask people to do things, people actually start creating their own scripts and their own tools to actually perform these tasks. So when something comes across as being easy to generalize, we try to make sure that this is also accessible to other team members. And so over time, we're actually building this database of tools that everybody can use for their specific problems. And so we're moving towards automation. It's just like it's a very slow process because, as you may guess, we have very different types of models and not everything can be reused for other models as well.
Do you have some kind of tool or platform in place for deploying and managing the various models, or do individual teams do that themselves for their own services? I guess, part of the question is thinking about it like what's happening on the dev side of things. Folks are forming, DevOps teams around microservices that, have full lifecycle responsibilities for those services. Are you doing similar things around models?
Yes, so we're moving in that direction. So we're developing our own compute platform where essentially all models will be trained. And so that platform would actually be talking to the data like directly, right? I mean, but again, it's a very slow process because you have to train people to use that new platform. There are some paradigms that are not necessarily very obvious to everybody. We try to make sure that everybody gets to use their favorite language in that platform, but essentially we're also loading that compute platform with the tools I was mentioning before, so that everything is in one place. Everybody's aware of what tools exist to make your life easier as a data scientist or a machine learning engineer.
And is this a homegrown platform or something that you're?
Yes.
Okay. I'm imagining when you talked about the monitoring the inputs and outputs of the models, that struck me as really interesting. And I imagine some platform that, you would tie into a monitoring system that when you're, as part of your documentation phase, you're able to describe the expected bounds of a given model. And then this thing is monitoring the inputs. And if you start seeing inputs outside of the bound, this thing would shoot off, red flags and start paging people. Have you gotten there yet, or is that part of what you're working towards?
Yes, absolutely. Absolutely. This is exactly what we're trying to do right now, right? I mean, so it's the challenge with this specifically is that when you have supervised models and like a numerical data set, it's fairly easy to monitor the inputs, right? I mean, so for some other models, like especially NLP based models, how do you keep track of, the language is changing right now among the Walmart customer, right? I mean, so it may be more or less complicated to actually monitor these inputs, but you are definitely developing that, right? I mean, so for some of the models, it's actually already in place where essentially whenever an input goes outside of like -2 sigma plus 2 sigma boundary, it's actually shooting an email to the person in charge of monitoring the model, and they would actually know that, something is potentially about to happen, right? I mean, so we're definitely geared towards this. One thing we definitely want to achieve in the near future is a model that allows you to understand that your model is expiring before it's time, right? I mean, so right now, I think most companies are thinking of retraining models in terms of a regular sequence, right? I mean, basically, I retrain my model every other week.
Right.
Question is, when you're in retail, there may be lots of happenings, there may be holidays, and sometimes you have to retrain things faster. unless you have something in place to let you know that the model is about to change or needs to be updated, you would actually learn that by a customer complaining about getting the wrong results or something that's not accurate or relevant to their searches, right? So you don't want that to happen, because it essentially involves that the customer needs to have a bad experience for you to be aware that something's wrong with your model. And so we want to make sure that we can catch these problems early in the process before it actually impacts the customer.
Mm-hmm. And so what are some of the methodologies that you use to identify these expiring models?
Well, it's about like finding the right metric to actually assess the satisfaction of the customer, right? But I don't think there is like a one true only metric that works for all cases. But again, it's the mission of the measure team, right? Measuring things and so on.
So in other words, when the model
dissatisfaction.
Sorry for cutting you off, but just to paraphrase, in other words, the model is expiring when it stops performing. There's not some other dimension to it.
Yeah.
Right. Okay. Interesting. As part of this measure team, you also are chartered with specifically looking for weaknesses in other people's models. What does that look like, and how do you approach that? And I guess I'm thinking of, looking for corner cases or, cases in the data that these teams might not have thought about that, based on your experience, you could foresee causing poor model performance. How do you approach that part of the role?
There are definitely two components to it, right? So there's definitely like weaknesses that you would see, like a specific model that requires like a frequent training or is extremely sensitive to seasonality would be something that we would like to look at and try to figure out like what is causing this, right? So the way we do that is we essentially keep track of, for example, assume that your model is something like a logistic regression model, because it's easier to explain. So you would be able to see like what parameters are extremely stable over time and essentially don't change even when you will train the model, and which one of these parameters are actually extremely volatile and have a very big error to it, right? So we would actually understand very with precision what parameters are causing the model to underperform. So that's kind of like a reverse engineer other people's model in order to understand what the weaknesses are. So that's one thing we do, and we're trying to kind of automate. The other piece is, like something which is like, like something you have an inkling that requires to be updated, right? So an example of something we've tried to do recently is that we were trying to add the notion of geolocation to actually personalize the results depending on your location in the country, right?
Okay.
And so you know that this needs to be taken into account, and you know that you're going to add that feature in the model. But the question is like, what is your best data set and your best bet to actually add that to the model, right? This is why we have statistical analysts trying to assess the quality of the different data sets that we have available. So this is where our job actually gets interesting, because we get to touch to lots of different data sets across the company, right? And try to understand, what is a data source that we could use to actually improve these signals and make our search engine better?
So do you have, this maybe goes back to our platform discussion a moment ago, but is there a place that has a dashboard of all the models that are running in Walmart? I guess I'm wondering at the granularity at which you track this. Like, do you have a master view of all deployed models and their performance, and you can do trend analysis across this and see, where logistic regression, types of models work versus other things? Or are these things managed more on a product by product basis?
No, we're definitely geared towards, like, at least for search. We're definitely moving forward to a phase where we get to see a holistic view of all models in production at one time, right? So basically, if lots of your models are using the same base model, like it's fairly easy to do. It gets more complicated if you have many different types of machine learning models in production. But we definitely believe that you should have a comprehensive view of everything. For the reason we mentioned earlier, that you have some crosstalk happening across models, right? It's possible that the fact that one model is underperforming is caused by another one overperforming. And so we believe that you cannot keep things segmented and just keep track of one product at a time. time. I mean, I really strongly believe that having a comprehensive view as much as possible is really important. Getting to the level where we have a comprehensive view of all the models across the company is going to be very challenging, as you can imagine, but that's definitely something I would love to see happen. Right? So,
to what extent do you use machine learning models to manage these models? And how do you do that?
That's definitely what we want to do, right? I mean, I sometimes call my team the team that creates like machine learning models of machine learning models, right? I mean, so essentially, the way you would do that is essentially using the parameters of the other models as a feature for another model, right? I mean, so basically you're kind of, as you mentioned earlier, right? I mean, you want to monitor things over time. So essentially like a trend analysis would be something that would, you could eventually use machine learning for this type of management.
And are you doing this at all today, or is it more directional?
Getting started.
Okay. Interesting. Yeah, I can imagine if you have all of your model data, all of your parameter data, all of your performance data, then part of what your measure team is able to do is someone brings you a model and some data, and you can just run your meta model against it and predict whether their model is going to work or not. It sounds like a great application.
Yep.
Awesome. Is there anything else that your team is focused on that we haven't talked about so far?
Well, I mean, we've covered most of it. I mean, the one thing is, like I mentioned, this effort to actually bring the stores data together with the online data. So this is an effort we started pretty recently. One of the challenges we're trying to tackle is the following. So search is actually an interesting problem because as you can imagine, we're using like lots of different data sources to rank the items we're showing to the customer, right? And so essentially we're using data related to the content of the items. So if somebody searches for TV Samsung, you want to show them, the right brand and the right product for sure. But then the question is, among Samsung TVs, which one do you want to show first, right? And so the answer to that is you're showing the one that is the most popular. So we sometimes run into a problem because think, for example, of a smaller type of item that you would usually buy in the store, right? I mean, so sometimes people connect to a Walmart.com website, they enter a search, and they actually decide to go buy that item in store. So the reason why they actually searched for that item was to check the inventory in their local Walmart store, right? I mean, and so for us as the search team, this is really a problem because if you see someone click on an item, but eventually they don't purchase it, we take that as a bad sign that we didn't show the right item, right? And so essentially that would cause us to demote that item over time. And it's very possible that the item that we showed was actually the one that the customer meant to see, right? I mean, and so it is very possible that eventually they bought that. So closing the loop with that and actually attributing a specific store purchase to a specific online search is something that we're trying to do now, right? I mean, so I think people have heard of the new Google attribution, right? I mean, they actually get to track you when you shop in store as well as online. I mean, we're trying to do that for essentially mapping mapping the gap between the stores and the online experience.
And that's what the data lake enables you to do by pulling all that information into one place and allowing folks to build models across it.
Yeah, definitely.
Interesting. And to what extent are you using external data sources in building your search models?
So we do, I don't know that we're using a lot of data sources. I mean, the external data sources we essentially use is I would say for monitoring purposes, right? I mean, so for example, we're trying to catch instances where we have a cold start problem, right? I mean, so if something doesn't sell really well at Walmart when you actually know this is a very popular item on the marketplace, you would try to do something about it. But we don't necessarily use that to create and build new models. We're essentially focusing on our own data at this point.
Got it. All right. Well, this has been a really, really interesting conversation, and I appreciate you taking the time out to chat with us about what you're up to. I think folks can learn a ton about the machine learning lifecycle management challenge and learn a ton from the way you guys have taken it on at Walmart. I really appreciate you taking the time to join us.
No worries. I mean, I always love talking about this topic, so my pleasure.
Awesome. Thanks so much, Jennifer. All right, everyone. That's our show for today. For the notes for this episode, head on over to twimlai.com/talk/46. Whether this is your first or 50th show, I want to thank you so much for listening. I really want to hear from you, so please take a moment to comment on the show notes page or on Twitter with your feedback or questions, or just what you found most interesting and useful about this episode. Also, if you share your favorite quote via a comment or social media, we'll send you one of our fab laptop stickers. Another thanks to this week's sponsor, Cloudera. For more information on their data science workbench, or to schedule your demo and get a free drone, visit twimlai.com/Cloudera. If you subscribe to my newsletter, you already know that I've got a busy month ahead as far as events go. The week of September 18th, I'll be in San Francisco for the O'Reilly Artificial Intelligence Conference. There's also a chance that on Saturday the 16th, I'll make it to the Scaling Deep Learning Conference in SF, which looks to be an interesting one. The following week, I'll be at Strangeloop, a great technical conference held each year right here in St. Louis. Now, I love meeting up with listeners, so if you're planning to be at any of these events, please drop me a note via a comment, the contact form, or Twitter. For more info on any of these events, check out the show notes. Thanks again for listening, and catch you next time.